Today I will introduce you to my project on electric scooters. So this right here is my Razor electric scooter, and my batteries were not working, so I took it apart and I'm going to be replacing them with new ones today. So for those who don't know what an electric scooter does, this twist button you see right here is the accelerator. And this wire right here leads to this aluminum control board, which is used to control the speed as you accelerate this thing. Now this right here is the braking system. And these two wires, one leads to the control board, the other one is this cable right here. And you see, as I press it, it will moderate how this wheel rotates. So it will basically put pressure and resistance towards this wheel. If you can see it closely. So these are the two basic functions of the scooter. It is controlled by this plate right here. As you can see, there are a lot of wires, and they all connect to some output peripheral. So these batteries, let's for say, is a peripheral of this control board, because these both send 12 volts, and I use this multimeter right here to record this. Alright, so going on with these batteries, both of them, each individual battery is 12 volts, and they are connected in a series, which means that voltage adds up, as I've mentioned in one of my previous videos, and the current stays the same. Now this here is our motor, and this takes up to 24 volts. Alright, so this here is our charging adapter, which goes into this port. So this charging port here supports up to 1500 milliamps, which is equivalent to 1.5 amps of current, and 24 volts. It supplies 24 volts. This control board here, let's talk about it. It has three major functions, one of which is battery cutoff and flow. So it controls the flow of the battery. And then the second one is the speed. This accelerator knob that I discussed earlier is controlled by this control board. And then the brakes that I talked about is also controlled by this. So all three are regulated just within this one small box. So now, before I move on to putting the batteries inside of here, let's go ahead and measure using the multimeter, the voltage. So first things first, you want to make sure that it is set to this V right here if you have a multimeter. Once it turns on, you want to make sure that it is in DC. Now that it's in DC, we can measure the voltage of these batteries. And we always must have it in DC because these batteries are measured in DC. Red indicates positive and black indicates negative. If we put it together, you will see that it is near 12 volts. So this battery is fully charged. Now let's take a look at this battery. As you can see, we are 0.5 volts off, which means it needs a little more charging, but that's no big issue. Now that we have covered the detail of this scooter, let's go into the assembly of the video. So, first things first, we want this motor to go right here because that's where it belongs in the scooter. This is how you do it. First, put the scooter down like this. And then this is the tricky part. You have to kind of nudge it between these two rods right here. And once it's properly secured, you can just bring it back up again. And now just align it properly. And that's how you place the motor. Now we cannot just leave this wire hanging. So on the very side, right here where my finger is pointing, there's a hole where these two wires can go through. And we just want to snug them through here. Now this brushed motor is connected to this wheel via chain. And how we want to connect this chain, there's a tensioner right here that retains the tightness. So this tensioner right here, we want to pass the chain over it. So we must bring it down a little bit in order to make it easier on ourselves. So now that this tensioner is brought down, with my hand I can easily just snap this chain onto the motor. Now I can let go. And this is what it looks like. Now, using a Phillips screwdriver, we want to put this motor in place so it remains intact. So this is what the screw looks like. Now that all the screws are set in place, I will be tightening each one of them. Okay, now this control board, we want to hook it up in place within this body. So this hole right here, and then this hole right here will go into these designated spots. So it is a little tricky with all these wires in the way. So now the control board is set in place. So we can just quickly tighten up these screws. And then next we will attach the motor cables with the control board cables. Alright, so what I have in my hand here is this white connector that goes through these two wires. And it's coming from the motor because there's not enough room here. But guys, one thing I advise you to do is before you take anything out or dismantle it, please have a reference or a picture. Because if you don't have it, then sometimes what may happen is, let's say you switch these two by accident. The motor will start running in the opposite direction, which is really not ideal. So it is important to have a reference at all times. So now, we want this blue wire to go in here. Alright, and once you hear that snap, that means it has locked in place and it's secure. And there you go. We have successfully connected it. Now I will be connecting all of these wires together. And if you don't have a picture, don't worry. This time you will be saved. Because these sockets are made such that it won't snap if the wrong one goes into place. Each one will snap into the right place only. Now we have these batteries inside of the body. But what we want to do is connect it in a series. So we take this wire, they're practically the same wire as they come from the reset button on the other side. And if we want to connect them in series, one wire must be attached to this battery while the other must be attached to this. So positive in one and negative in the other. So it will go like this. So now, since this connection has been done, it is in series. And if you don't believe me, I will show you through this multimeter. Now as you can see, we have gotten 22.3 voltage output, which is not exactly 24 volts, but we will charge it up and then it should be 24. Okay, now we have finished the whole assembly. It's time to close this up and we will get this beast running once it is charged.